We're asked to determine a piecewise smooth curve for the given curve shown below, where the curve C is equal to C sub 1 plus C sub 2. Notice how curve C sub 1 goes from the point 0, 0 to the point 4, 6 along the line y equals 3 halves x. And then for curve C sub 2, we want to go from the point 4, 6 back to the origin along y equals 3 times the square root of x. To determine a piecewise smooth curve, we want to write parametric equations for C sub 1 and C sub 2. Let's first focus on C sub 1. Again, looking at the orientation, notice how the x values go from 0 to 4. So let's go ahead and let x, or x of t, be equal to t, where we'd have t would be on the closed interval from 0 to 4. And therefore y, or y of t, is equal to 3 halves t. Now for curve C sub 2, again we want to go from 4, 6 back to the origin along the curve given by y equals 3 times the square root of x. So in this case, because the x values are decreasing, and we know that t has to start at 4, we cannot just let x of t be equal to t, but because the change of x is 4 units, and we know t has to start at 4, let's let the interval for t be from 4 to 8. So we want an equation that when t is 4, the x value would be 4, and when t is 8, the x value would be 0. And therefore x of t would be equal to 8 minus t. Notice how when t is 4, x is 4, and when t is 8, x is 0. And therefore y of t would be equal to 3 times the square root of, well, if x is equal to 8 minus t, we're going to have the square root of 8 minus t. These parametric equations make the curve C a piecewise smooth curve. Let's also write this as a vector-valued function. We can say that r of t is equal to, well, for curve C sub 1, the s component is t, the y component is 3 halves t, where t is on the closed interval from 0 to 4. And for curve C sub 2, the x component is 8 minus t, and the y component is 3 times the square root of the quantity 8 minus t, where t is on the closed interval from 4 to 8. I hope you found this helpful.